attend a free live class, download the app now.
Hello everyone. Good afternoon. Hi Shravya. Okay, Trikwala Santara Gautam. Okay, so such a big name I got over here. Prakati, Assam, Diksha, Banu. Hello everyone. How are you all doing in this very fine afternoon? Tell me that. Abhilash, Azan, tell me how you all doing. And tell me how was your max class? Those who attended the max class, tell me how was it? Was it awesome? I think the teacher must have given you an awesome lecture, right? Okay, all good, happy. Okay, Prajwal is there, my Kerala friend. Good. Okay, awesome sir. Okay, good. That's a great thing for me to listen. So, for those who don't know me, myself Ameer Basit, Master Teacher of JEE Physics at Vedantu. You can call me Ameer for anything and everything, but only for physics, right? Okay. So, for so many of you might be knowing why we are here, right? For preparing ourselves for the upcoming board exams. By doing what? By doing a lot much of previous year questions. Okay, so we done enough chapters. So I know that whoever is regular to my class, these are the topics which we have already covered till 1st of Feb. So don't worry, those who have missed the topics, go and watch it in the YouTube. It is still available. It will always be available, right? Okay, so many are telling I'm all good, Pragar. Okay, thanks for asking. Pragati, good afternoon. Okay, right, so I hope you can take a screenshot whichever topic you're feeling difficulty. We have done enough question in all those topics, and not only this, we have completed the moving charges and magnetism part 2 also in my last class. Okay, so today as we are on the 5th of February, we will be starting with magnetism and matter. So which chapter we are going to do today? We are going to deal with such a theoretical chapter which is magnetism and matter. So are you all ready for it? Yes, I'm going to start. Don't worry at all, Sneha. Okay, I'm going to start. So before starting, I have to tell you, for so many of you might be having difficulty with a particular chapter only, right? Okay, thank you so much, Sukriti. So for those people who's having difficulty in a particular chapter, Vedantu is offering micro courses, which means you can buy a single course, a single chapter. And how much does it cost? Do you know how much? I think you won't even think about it. The price you have to pay for that is just 9 rupees. Okay, not 9,000, not 900, not 90. It is just 9 rupees. Go and buy it if you're having any issues with any of the chapters. Okay, magnetism is what we are going to start. So tell me, are you all ready for the chapter to begin? Are you all ready? All good? Tell me yes or no, because I don't want the chapter to be this session to be so dull. I want the entire session to be so active and chill, and I want every one of you with me. Yes? Good, happy, then let's go. So today we'll be mainly dealing with 1 mark questions. Okay, so I'll be explaining the theory in detail. If you're having any doubt, let me know, I'll clear it out. Okay, not Menti quiz, we are mainly concerned with board exams, so there won't be a quizzes. Okay, so first question. A toroid of n turns, its mean radius between the average radius is r, cross-sectional area A, carries a current I. Okay, it is placed on a horizontal table taken as xy plane. Its magnetic moment. Okay, I hope you know what is magnetic moment, right? It is a measure of magnetic dipole, right? Magnetic dipole means magnet with a north pole and a south pole. So I hope you might be knowing this particular thing also about a current carrying conductor. What? So let me draw this. Okay, so if you are having a current carrying loop, suppose I'm taking not a single loop, I'm taking a loop which can be called as a solenoid. So I'm taking a solenoid with n number of turns. Okay, and if a current of I is passing through it, think that a current of I is passing through this solenoid. What will this current carrying solenoid will be acting as? What will this be acting as? What will this be acting as? What will a current carrying loop will be acting as? Tell me fast. Very good. It will be acting as a magnetic dipole or a bar magnet, right? With a north pole on one side and south pole on another side, right? If the current is going in the anti-clockwise direction in the loop, which pole will it be acting as? Let me know who all are so brilliant over here. If a current is passing through the loop in the anti-clockwise direction, it will be acting as north pole of the magnet, right? Why? Because if the current is moving in the anti-clockwise, by using the right hand thumb rule, if you keep the thumb in the direction of the current, the field lines will be coming out, right? Very good, Ritesh, Shruti, Anu, Adul. Okay, so similarly, if you have what, a magnetic dipole over here with a north and a south, which you can see the field lines are emerging out from where? North, right? So that's why whenever the current is in the anti-clockwise direction, it corresponds to north pole, right? Okay, very good, Prajwal, thumb rule. Now what we are doing over here, this particular loop or the solenoid, I am going to close it, which means I am going to touch both the ends and make it as a toroid. Okay, so this particular solenoid, I am closing it on both the ends. So if you close the solenoid and close it on both the ends, what do you call it? You call it as a toroid, right? You call it as a toroid or not? Yes. Okay, so once it is toroid is being made, can you see a north pole or a south pole in that toroid? Can you see a north pole or a south pole in that toroid? You cannot see. Why? Because both the ends are being closed. So now that solenoid, when it is made into a ring form, you cannot see a north pole and a south pole. So that won't be acting as a magnetic dipole. If there is no magnetic dipole, will there be a magnetic dipole moment? Can we measure the dipole at that moment of time? No, right? Which says the dipole moment is what? What is the dipole moment? What will be the answer now? The dipole moment is 0. Very good. So which option we can go for? We can go for the option C, right? I hope everyone might have understood this, right? Such a beautiful question with much of concept inside it, right? Okay, very good. Lakshman, Shruti, Prajwal, Sravya, everyone is giving me the answers. So let's not wait. Let's move forward to the next question. What does the question says? In a permanent magnet at room temperature. Okay, so if it is about a permanent magnet, you should be knowing what is a permanent magnet. What is a permanent magnet? A permanent magnet is a ferromagnet, right? A ferromagnet, right? And if it has to be a permanent, it has to be a hard ferromagnetic material. Hard ferromagnetic material is being used as a permanent magnet, which means it will always be acting as a magnet, right? Okay, now we have to know about the ferromagnet, right? Okay, how is the ferromagnetic properties or the dipole moment of a ferromagnetic material is described? How will you describe it? You know that inside the ferromagnetic material, all the atoms have a dipole moment, and all the atoms which is sharing a common dipole moment will be doing what? Which will be forming a common dipole moment, will be forming as a group, right? So suppose, 1 minute. Okay, so I'm taking a ferromagnetic material, right? So inside the so many atoms are there. Each atom is will be acting as a magnetic dipole. So those atoms which are sharing a common dipole moment or dipole moment in the same direction will be forming as a group, right? So this group which is sharing a common dipole moment or in the same direction is called as what? A domain, right? So what will happen to all this domain when it is kept in an external magnetic field? All the domains will be aligned in the direction of the external magnetic field, which means in this direction, right? Yes, so this will be the direction of the permanent magnet when it is kept in an external magnetic field. So once you remove it, as it is a permanent magnet, it has to retain its magnetic property, right? So though it is retaining, the entire magnetism won't be retained, some will be lost. How some will be lost? Some of the domains will be aligned in other direction, the others will be aligned in the same direction, which means the material will be possessing some of its magnetic material because of a partial alignment of domain in a particular direction. So which option we can go for this particular question? In a permanent magnet at room temperature, domains are what? How the domains are aligned? The domains are partially aligned. Very good, Ritesh, Shruti, Shubhankit. So everyone is understanding. It's a great thing, right? I hope everyone understood the question. Say yes or no. Yes or no, say yes or no. All good, happy? Yes, susceptibility we'll discuss about. Don't worry about it. Yes, very good, Prajwal, my Malu friend. Yes, okay. Next question we have. A magnetic needle is kept in a non-uniform magnetic field, it experiences. What all will it be experiencing? So let's check it, right? Okay, so we have a dipole. Okay, we have a magnetic dipole. One is of north, the other is of south, right? Okay, the strength of the north pole, I am marking it with plus small m. The pole strength of the south pole, as it is being written with the negative m. I hope you know, just like the positive charges and the negative charges, right? What you have in electrostatics. If it is kept in an external uniform field, okay, we'll discuss about non-uniform. First, let us discuss about non-uniform magnetic field. So you have a non-uniform magnetic field in this particular direction. So if it is kept in a non-uniform magnetic field, this pole strength will be experiencing a force, right? Just like what? If you are having a positive charge and a negative charge, if it is kept in an external field, what will happen? It will be experiencing a force. How much? Q into E, right? So similarly like that, this will also be experiencing a force. How much will it be? Okay, there you have charge, here you have the pole strength, there you have electric field, here you have the magnetic field. So this will be the force experience, right? So here it will be in the direction, north pole will be experiencing the force in the direction of the external, and south pole will be in the opposite direction, because it is attraction and this is repulsion, right? Okay, so this will be M into B. What about the forces now? What about the force now? What about the force? The forces are equal and opposite in the case of a uniform magnetic field. So net force is 0, right? Net force is 0. What about the torque? Is it producing a torque? Is it able to rotate this particle? Say yes or no. Yes or no, is it able to rotate a particle? Yes, so it is able to rotate the particle because a force is applied like this. Okay, think that you are having a thing like this. Okay, a bar is there, I'm applying a force in this direction, one in this direction. Won't it be rotated? Yes, it is getting rotated, so a torque is being produced. So here in this case of uniform magnetic field, a torque is there, force is not there. But if the field is not uniform, here if it is MB1 and here if it is MB2, non-uniform means field is different. So if the field value is different, what will happen? If the field value is different, there can have a net value of force also, right? Because net force will be equal to MB2 minus MB1. Okay, it is not getting cancelled because the field is non-uniform. So in this case, non-uniform magnetic field, a dipole will be experiencing what and what? A force and a torque, right? Both it will be experiencing. We can go for the option C. Very good. Prajwal, Ashish, Ayush, Ruman, Shruti. Okay, so I can see that Josh in the class, activeness in the class, energy in the class. I'm so happy for that. Okay, keep this going till the end of the session, right? So shall we move to the next question? Shall we move on? Yes or no? Okay. Okay, we'll clear the doubt in the is it about this particular topic, Prajwal? Is the doubt about this particular topic? Please type in if it is about this topic which we are discussing. Okay, so we have the next question. It is a simple question only. Okay, so the question says what? 3 needles, N1, N2 and N3. Needles mean take it as a magnet. Okay, so 3 magnets we have, N1, N2 and N3. They are, first one is made of a ferromagnet, the other one is of paramagnet and diamagnet substance respectively. Okay, a magnet when brought close to them, what will happen to each one of them? What will happen to the ferromagnetic material when you are brought in an external magnetic field? What will happen? Think that you are having a material. Okay, so this is an external magnetic field. So, or think that this is a north pole and the south pole. This is the external bar magnet which is producing the field. So field will be in this direction because the field lines is emerging from the north of the magnet, right? Okay, now you are keeping initially a ferromagnetic material. So when you are keeping a ferromagnetic material, what will happen to the dipole? It will be aligned in the same direction, right? So the dipole moment of this ferromagnetic material will be aligned in the same direction. So if this is the direction of the dipole moment, here south will be induced and north, because dipole moment is always directed from south to north. So this north will always be attracting this south in a very hard fashion because it is ferromagnetic material. So What? N1 will be attracted strongly. What about N2? Paramagnet. Same thing happens, but the dipole moments are very less, so it will be less attracted. And what about diamagnetic material? When it is kept in an external magnetic field, in the case of a diamagnetic material, what happens is that, so if this is a diamagnetic material, think that this will be aligned, or the dipole moment of the diamagnetic material will be aligned in an opposite direction of the external magnetic field, right? So what will happen? If this is the direction of the dipole moment, here it will be south, here it will be north, right? So in the external field, this north and north will be repelling each other. Yes or no? Yes or no? So which option we can go for? N1 is strongly attracted, N2 is weakly attracted, and N3 is weakly repelled. So we can go for the option D. Yes? Happy? All good? Next question. So where is the next question? Why it is not coming? Okay. Next question we have. Look. Good. So many answers. Okay, thank you so much. Everyone is so active. I'm so happy for that. Next question. Okay. The material suitable for making electromagnets. What are electromagnets? Electromagnets are temporary magnets, which means when you switch on the device, the magnetism should be there. Okay, when you switch it off, magnet shouldn't be there. So such a kind of material is called as electromagnets. Okay, so now we have to talk about the two properties, which is retentivity and coercivity. What is retentivity? The ability of a magnet to retain its magnetism though the external field is zero is called as retentivity. And what do you mean by coercivity? Coercivity is the amount of external magnetic field you have to apply to make the net dipole moment or the net field inside the magnet zero is called as coercivity, right? So that is retentivity and coercivity. For the electromagnet, okay, though we make the external field zero, the magnetism shouldn't be zero at the moment itself because of safety reasons. Supposing that the current is gone during the working of an electromagnet. If the current is gone, external field will be gone. If the external field is gone, what shouldn't happen? The electromagnet shouldn't lose its magnetic property all of a sudden just like that, because it will cause many problems, right? So it should have some magnetism retained with it, which says the retentivity of the electromagnet should be more, but the amount of external field that you have to apply to cancel the field in it should be less, right? Because whenever we switch it off, the electromagnet should be converted to as a normal material, or the magnetism should be lost. So it should be having what? What is the option? It should have high retentivity and less coercivity. So we can go for the option C, right? Guys, are you able to enjoy this, or should I just do the question and the answer? Hi Vibi Wizard. Hi Vivek. So tell me, should I have to continue the questions by explaining in such a manner, or should I be just doing question answer? Okay, retentivity I'll tell. Enjoying? Is this fine? Everyone? Okay. So someone asked me what is retentivity. I'll tell once again what is retentivity means. Though we remove all the external field, whatever is the magnetism remaining in that material is called as retentivity. How much magnetism is retained though the external field is removed is called as what? Retentivity. Simple as that. Susceptibility, a question is coming related to that. At that moment we'll discuss. Okay Akshat, don't worry at all. Thank you so much. If you're enjoying, continue. Fine sir, ja rahe hai. Very good. So let's go with the first question. Second question, sorry, next question. Slip of tongue. Okay, so lines of force. Okay, where the force is coming? Because of the external magnetic field, right? So if you keep a magnetic material in an external magnetic field, it will be experiencing a force in the direction of magnetic field, as you know, right? Okay, so due to Earth's horizontal magnetic field, you know that Earth is producing a magnetic field at each point, right? So that magnetic field will be having a horizontal component of magnetic field and a vertical component. Now we are talking about the horizontal magnetic field, which is horizontal or parallel to our surfaces. Okay, so if this is the surface, the what if this is a surface? Okay, let me draw it over here, it will be more useful so you can understand it better. Look, if this is a surface, at each point there will be a magnetic field aligned in any particular direction, right, making some angle theta, which is called as angle of inclination or angle of dip, right? Okay, so if you take the horizontal component, this will be b cos theta, right, the horizontal component of Earth's magnetic field. You can see that it is always horizontal to the Earth's surface, right? So it is parallel to the Earth's surface also, and always it will be straight lines, right? So this is the direction of the magnetic field. In this direction itself, the force will be felt also. Yes or no? So the forces that is experiencing because of horizontal component of Earth's magnetic field is parallel and straight lines, right? So which option? We can go for the option D. Yes, good, happy. Yeah, we have planned to take one more question because so many were asking for one more question, because it will be more helpful, because with one more question I can explain lot many theory also. Okay, so you are talking about my ability to teach you, right? Okay, I'm from NIT. I did my mechanical engineering, BTech in mechanical engineering. Okay. Fine. Okay, very good. Let's move forward. So this is a Telegram group. Okay, so before going to the next question, I just have to introduce this. So all the teachers are available over here. You can take this link and join our Telegram group, and whenever you feel any doubts, okay, you can post it in that group. Teachers will be there to give the answer, right? Yes, mainly theories. Don't worry, you don't have to be afraid of physics. Okay, so this is what I have to tell you guys. So this is our Telegram group. For any updates or if you have any doubts, you can post it in the group. So people, all the teachers, all awesome teachers in our country is there to give the doubts for you. Okay, next question. Very good. Why the next question is not coming? Okay, so the next question is about what? If the magnetizing field on a ferromagnetic material is increased, its permeability. So someone will be having the doubt about magnetizing field, which means intensity of magnetizing field, which is called H, and intensity of magnetization M, right? So H and M, I hope everyone is having a doubt. So let's clear it out. So how am I going to explain? Let's see. Think that you are having a magnet, okay, and you are having an iron nail. When iron nail is not kept close to this bar magnet, what will happen? Its magnetism is 0, right? Okay, now whenever you keep this iron nail close to this bar magnet, which is producing an external magnetic field, this will get magnetized, right? Okay, isn't it? Yes or no? This iron nail will get magnetized. The extent to which this iron nail will get magnetized in the presence of this field or this external field is called as intensity of magnetization. Intensity of magnetization, which is written with the letter M. Okay, then one more thing is there, intensity of magnetizing field. What is intensity of magnetizing field? Okay, so it is producing a field, right? This external field, what is it doing? This field is trying to magnetize this material. So the intensity of this external field to magnetize another material is called as what? Is called as intensity of magnetizing field, which is written with the letter H, and the ratio between them is called as susceptibility, M by H. What you are giving is H, what is happening inside the material is M. Okay, so once you give this external field, and if this get magnetized in the same direction, both are in the same direction, this will be positive. That is what is happening in paramagnetic material and ferromagnetic material. Why it is negative in diamagnetic material? Because though you are giving H in this direction, external magnetic field in this direction, the direction in which this is getting magnetizes in the opposite direction. That is why the susceptibility of diamagnetic material is negative. Understood till here? I hope everyone, right? Okay. Now the question is about permeability. What is the formula? Mu is equal to, permeability is equal to 1 plus mu relative is equal to 1 plus susceptibility, right? That is 1 plus m divided by h. Okay, now the question is, what is happening to this permeability for a ferromagnetic material if the magnetizing field is increased? If this h is increased, what will happen to this ratio? This will decrease. If this decreases, entire permeability will decreases. Yes or no? So which option? Which option we can go for, guys? Tell me which option we can go for. We can go for the option A. It gets decreased, right? All good? Happy? Understood till here? Yes, it's for option A. Okay, Abhilash is also a Malu. Okay, so many Malu friends are here for me. Okay. Next question. Unable to understand why? Why you are not able to understand what happened? Okay, next question I'll try to explain in a better manner. Okay. Okay. So many Malu groups are here. So next question. What does the question says? A magnet, a dipole moment M is aligned in equilibrium position in a magnetic field of intensity B. Okay, external magnetic field B is there and you are having a bar magnet of dipole moment kept in that external field B. The work done to rotate it through an angle theta with the magnetic field is, okay, they are asking for the work done to rotate it by theta. Initially, what was the position of this dipole? It is told that it is in equilibrium position. If it is in equilibrium position, the energy that the dipole possesses should be very less, right? Okay, so you know that whenever a dipole is kept in an external magnetic field, what does it have? It has an potential energy given by the formula. What is the potential energy? Minus of mb cos theta, right? Okay, so it will be in equilibrium whenever it is stable. It will be stable when the energy is less. When will the energy is less? Whenever this is having a least value. What is the least value possible? That is minus of mb, or when the cos theta value is 1, right? When will the cos theta value will be 1? When theta is equal to 0. So initially, what is the energy? Minus mb, right? Because it corresponds to what? Equilibrium position, right? Okay, now from the 0 angle, it is being rotated to an angle of theta and they are asking for the work done. So work done is equal to how much? How will you find out the work done? Work done is equal to change in energy, right? Change in potential energy. I hope everyone might have studied from the chapter work power energy, right? Okay, so that is equal to u2 minus u1, right? Okay, so what is u1? We have already found out. It is minus mb, right? So this is this minus, this is of this minus. What is the final potential energy? That will be equal to minus mb cos theta, because we are rotating it by an angle of theta, right? I am writing it over here. So that is minus mb cos theta, right? This negative and this negative will become plus. So if you take mb outside, mb into 1 minus cos theta. So which is the option? We can go for the option C, right? All good? Happy till here? Understood? Yes, very good, very good. So we can go for the option C for this particular question. Next question. Magnetic moment. Understood now, Shravya? Okay, very good. Thank you so much. Okay, so your feedbacks are very important for me. So whenever she is not understanding, she told me. Now when she understood, she told me. It's a great thing. Okay, so that should be the quality of a good student. And let me try to improve myself as a good teacher also, to the best I can. Is a part of the formula. I'm a person who never try to by heart physics, because I love theory of physics. So I won't tell you have to learn physics by hearting all the formulas. Okay, so magnetic moment for solenoid and corresponding bar magnet. What is it? You know that a solenoid, a current carrying solenoid, will be exactly acting like as a bar magnet. So magnetic moment for both will be what? It will be acting as, it is for the corresponding bar magnet, Ridesh. We are talking about the corresponding bar magnet. Okay, so if you are talking about the corresponding bar magnet, means a solenoid which has the same magnetic dipole moment is being replaced by a bar magnet, because a solenoid can be act as a dipole, a current carrying it. So it will be what? Which option we have to go for? Yes, it is equal, Abhilash. Why you have to guess it? It is equal only. So we have to go for the option A. It is not equal anandu tonunu, Prajwal. You have to be damn sure about it. When you are in physics, you should be damn sure about the answers. Okay, trust yourself, because when you start trusting yourself, so many beautiful things will happen in your life. Yes. Haven't understood? I have told you a single thing only, Raghav. A current carrying solenoid will be acting as a bar magnet, right? A solenoid will be acting as a bar magnet. So if you are going to replace a solenoid which is having the same dipole moment as that of a bar magnet, okay, that is why it is said that corresponding bar magnet. What should be the dipole moment? What should be the magnetic dipole moment? It has to be equal only. That's why I have said it as yes. You are from class 10. Very good. Okay, so I hope you are understanding a bit, because it's a +2 topics. Guys, so this is all what we have got for today's class. I hope you guys have enjoyed. I know that so many things are learned for you, not only for this, for the coming exams. Yes, I'll be covering all the chapters. I have shared the topics and the schedules already with you. You have to go accordingly. Fine. Okay, so this is about the class 12 crash course which is happening. Okay, so what I have to tell you is, I know that if you can have some motivation and some people to make you good preparations, okay, the best people you can approach is Vedantu. Like me, so many good teachers and mentors are there for you. So you'll be getting the study plans for the board exam, last 5 years analysis of the papers. They'll help you in all the manner to get the best out of you. And how much you have to spend for this? Okay, this actually costs 12,000. If you can go to this particular link what you can see over here and apply this code AMECC, instead of paying 12,000, you will be getting how much? You will be getting this course for 3,799 rupees just, which will make your future super awesome, right? NCERT is enough. Yes, NCERT and the questions which is after the there is some exercises, right? What happens in NCERT plus the previous year question is more than enough to get you 98% in the board exam. So once you are good in that, that is more than enough for the board exam. So now you are attending my class, Magnetism and Matter, and don't go after this. You have differentiation with Ameer Sir at 2 o'clock. So stay here and watch his class. You are going to get a lot from him. Okay, so these are the results of Vedantu which we have done. Okay, and if you also want to be a part of it, come and join this Vedantu and put your photo over here. Okay, now what I want to tell you is, I hope so many of you, and I hope every one of you might have understood this particular sessions, right? Raghavi is telling awesome. So if you feel or if you think that Raghavi is right, which means if she's thinking that this particular session is awesome, if you agree with her, don't forget to like this. Okay, so it will be a great motivation for us so that we can do more and more videos. And if you think that this will be helpful for your friends also, don't forget to share it with your friends, and please do subscribe. Okay, subscribe means it's a great support for us, so we will understand that you need it more, so we can do more and more videos for you guys and all the younger brothers and sisters which is coming for the 11th and 12th standard, right? Okay, so thank you so much. Yeah, whatever is your doubt, you can put in the comment box. I'll be replying you. Okay, so thank you so much for subscribe. Okay, so just like Supangit, everyone go and subscribe for the channel. You'll be getting many awesome videos. Okay, Rajchandan, so I think it's time for me to say goodbye to everyone till we meet on Friday at the same time. I hope everyone will be there at the same time, 1 o'clock. Okay, and make it awesome just like you did today. So bye everyone, and we'll see next time. Okay, thank you so much.